not a medical doctor, but I knew a long time ago that studying ADA2 results in finding deficiency, actually. So let's say 10 years ago, I was so lonely studying this enzyme, and now I'm so happy to see so many people interested in ADA2. And honestly, when I submitted my first paper on ADA2, nobody wanted to accept it because people were thinking that there is only one enzyme, ADA, and there is no, and ADA2 is actually either enzyme of AD1. So today I'm going to, so what is new in this field, actually, my brother and my students, they found also a homolog of ADA2 in bacteria, which means that this enzyme is very conservative, and it's also probably secreted by bacteria as well. So we also developed several tests that are quantitative, so they're not they're based on ADA2 activity, but they give the concentration of this enzyme, and we are going to publish soon. But today I'm going to talk about some very simple thing. Okay, so this is skip. So we are trying to find the link between this function of ADA2 or adenosine deaminases and the function of adenosine receptors that were mentioned before in another talk. So just a brief introduction. So it was found that in tumors, the concentration of adenosine, extracellular adenosine, is increased compared to the concentration of adenosine in normal physiology and can reach about 50 micromolar level. And at this concentration of adenosine, adenosine can bind to adenosine receptors expressed of multiple cells. And normally the activity of this enzyme is immunosuppressive. So you can imagine if you add adenosine deaminases as AD1 and AD2, you can decrease the concentration of adenosine and activate immune cells. In the same time, we have found also that for children that have pneumonia in the bronchial lavage, there is a high concentration of adenosine deaminase 2, which is associated with severe case of pneumonia, and also it's associated with expression of multiple cytokines, including TNF-alpha, IL-6, and so on. So it means that if you can think about ADA2, you can think about ADA2 as a immunostimulatory molecule, which actually induces inflammation. So let's say if you remove this enzyme, in this case, you should have immunosuppression, immunodeficiency. But in fact, you don't have this, you get opposite. So, and I was thinking about this for a long time, and I couldn't get any explanation until we got cells from AD2 deficient patients. So here we use a very simple experiment. We just purify monocytes. We activate monocytes with liposaccharide, and then by adding adenosine, we can see that activated monocytes from healthy donors, they have decreased secretion of TNF-alpha. And actually, just to mention, in bronchial lavage, the concentration of adenosine is very high, so it can be up to 60 micromolar. So this experiment is physiologically relevant. So, and if you add the adenosine deaminases, AD1 or AD2 to the cells, I don't know, do you have? Winter. So, as I said, if you increase the concentration of adenosine, you decrease the secretion of TNF-alpha from the cells, from monocytes. And here is the case when you have a lot of adenosine. But if you add adenosine deaminase, which has a mutation, nothing happens. But if you have adenosine deaminase 2 or adenosine deaminase 1, you have increase in the production of TNF-alpha due to decrease of extracellular adenosine. So it's quite simple. But then we got samples from two different patients. One patient had monocytes from polyarthritis nodosa patient, is from Finland. And another patient had also leukemia type of phenotype. And if you compare healthy donor and the monocytes from the patient from polyarthritis nodosa, you can see that the monocytes from these patients, they do not respond to adenosine compared to the healthy donor. So next. So if you look on the patient with a large leukemia, a large granular-sized leukemia-like phenotype, you can see that the cells, they also respond to the adenosine similar to the healthy donor. So we can see that depending on the phenotype, you can get monocytes that do respond to adenosine and the monocytes that don't respond to monocytes. So next. So if we compare secretion of different cytokines from monocytes that with a patient with large granulocyte leukemia-like phenotype and polyarthritis nodosa phenotype, you can see that other cytokines, I can't see well, they also do not respond to adenosine. And in the case of this phenotype, you have a nice response to adenosine. So we know that we also notice that the concentration of TNF-alpha is much higher in the case of when the cells are getting activated, the concentration of TNF-alpha released from the cells from the patient with polyarthritis nodosa is much higher than from the cells that are either from healthy donor or from the patients with a large granulocyte-like phenotype. And the same was found for IL-6, MIP-1 alpha, and MCP-1, which shows that actually the cells that activated with LP, they are hypersensitive in the case when there is no ADA2, and it's only for the phenotype, the SPAN phenotype. And then I can make a conclusion that indeed it's very important to look for the phenotype, and for the patients with polyarthritis nodosa, it's clear that using the TNF-alpha inhibitors should be the main strategy for the treatment. So we also looked what kind of adenosine receptor could be affected on the cells with monocytes with polyarthritis nodosa patient. And we know that the decrease of the TNF-alpha is normally due to the activation of A2A receptors. So if you add A2A receptor antagonist, you actually have to increase the release of the TNF-alpha. And if you look for the healthy donor, actually it's true. So if you compare the test tube where you don't have antagonist, and when you add antagonist, you have increase in TNF-alpha. But in the case of the patient, there is no increase in the concentration of TNF-alpha. So, and also we have compared two patients with two different phenotypes, and you can see here, the first is the control, and second with the antagonist of A2A receptor. For the patients with polyarthritis nodosa, the monocytes, they do not respond to the A2A antagonist. And in the case of the patients with large granulocyte leukemia-like phenotype, there is a clear difference between the control and addition of this antagonist. So now we can make a conclusion. So first, that activated monocytes from the patients with polyarthritis deficient patients have low sensitivity to extracellular adenosine, and the cells express high levels of pro-inflammatory cytokines such as TNF-alpha, IL-6, MIP-1 alpha, and MCP-1. And what we can say is that different phenotypes of these AD2 deficient patients, the difference between phenotypes could be explained by the different compensator mechanism that was proposed before, or different environment, so which was developed in the absence of AD2. And I would say that it should be checked before you do the treatment, because there are really clear difference. So let's say in the case of the patient with polyarthritis nodosa, you need to use TNF-alpha inhibitors, but in the case of the patients with leukemia-like phenotype, probably you need to add ADA2, because if you add ADA2 to the patient with PAN, you will actually make it worse. Because because you will actually increase the production of TNF-alpha by activated cells. Okay, that's it. Thank you.